So I'm thrilled to introduce the next speaker. The name is Matteo. We have known each other for a few years now, and we spend a lot of time together working on Fastify. Hey, Matteo. And
Hi, everyone.
other cool stuff.
Hey.
So Matteo is a technical director at Nearform, a member of the Node.js Technical Steering Committee, obviously one of the members of the core team of Fastify. His normal day is 48 hours, not 24 like ours. Otherwise, I cannot explain how we can do so much stuff. So today, Matteo will talk us about GraphQL and performance. I never thought these two topics could live in the same talk. So let's find out how it will be. So how are you, Matteo? Are you ready?
Yes, really cool.
Great. So I leave you the stage and see you in a bit.
So, hey, hi, folks, hi, everyone. So please follow me on Twitter overall. I'll always try to remember this from people. So, hey. Anyway, let's talk a little bit about GraphQL. I hope all of you know what GraphQL is by this in 2020, but if you do not, let's do a little bit of a quick recap on why GraphQL is actually, might be or is a good idea. So first of all, GraphQL was born at Facebook. So let's use a little bit of Facebook-based examples. So let's say that you want to get all your Facebooks for all your friends, and you do a get. If you wanted to model this using REST, you would use represent this as a get of a friend's endpoint. This is nice, right? Pretty normal. And you will return an array or an object with an array, whatever, with the list of all your friends. Hey, good. But what happens if only you want the names? Because, you know, you have, if you see here, there's a lot of properties, right? Hundreds. So you might just want the name. So we need, if you just want the name, then why should we, here we go. Why should we include all those data? Why should we transfer all those data to the browser, or more importantly on mobile, that this data is not needed? So in fact, it can actually improve the end user experience by just returning less data, which is normally the case, by the way. So you might want to add a new endpoint called Facebook Friends Names, just returns names, or you just want to add a filter option. All of this is non-standard, of course, so you can't really do these type of things. You can really do this type of things on your own. Okay, so it's actually a little bit of a problem. So hey, so you know, but then the thing can get worse, because when you're rendering your page, right, you might want to do two calls. You want to add the friends and the likes. Ouch. So you're doing two HTTP calls. Now, you might not be aware that your browser, when you're loading a page, can open at maximum of 4. It opened a maximum of 4 sockets or something, maybe 8, whatever. Now they increase that. Anyway, it opens a limited amount of sockets to the server. Each one of those these days needs to do a full TLS handshake. This means a bit of a ping pong for about 200, 400 milliseconds in your code to actually set those connection up, so that they can actually transfer the files and your requests. So if you want your page to look snappy and fast, doing a lot of requests is problematic. So if you need to do one single request with the friend and the likes, if you want to do 2 requests with the friends and the likes, you might be tempted to do get Facebook friends and likes. Hey, so, you know, I don't know if you see where I'm going, but hopefully you will see it in a minute. GraphQL, it tries to solve this problem. It was invented by Facebook as a way to fully represent the entirety of Facebook data. Well, you know. So let's see how we can model this. GraphQL is a query language that you can use to query from the web or from mobile to your server. And with this query language, you can specify the query you want to run. So, for example, friends, and specify some parameter. In this case, in the name of the person, and then you can specify some properties. Now, you don't need to create multiple endpoints. You just write once, and then it's a runtime that decides which property to send. It's pretty great. and this is important because it only returns the name, right? Because I asked for the name. So essentially, if my mobile app needs only the name, I can send a query that only returns the name. Otherwise, if my browser needs all the data, it can actually return all the data. In this way, you can actually save a lot of bandwidth. Saving bandwidth means it takes less time to load your app, and it means your app looks snappier. So it's pretty cool. How do we model this? So you model this with a type query. This is what we call a GraphQL schema. And this is what you write. So you say that you need to define some top-level queries, for example, the query friends, with some parameters like the name as a string, which is a string, that returns a friend. Now, then you define your types, which is what a friend is, and you say there's a name, a country, and an age. Pretty cool. It supports some all basic types, and it's all typed. This is actually really, really great because we can do a lot of things with it. These I covered. So another feature of GraphQL is that you can use it to issue two queries in parallel. You can do a query with different 2 queries or 10 or 5 or whatever, and the runtime would actually pack them and send all the data back to you, to your browser or to your mobile. In this way, you can save a lot of round trips with the server. And each one of those costs 200, 400 milliseconds, blah blah blah, something like that. And this saves actually some time and can make your application feel way, way, way snappier. Again, it seems pretty cool, right? Why should don't we want to use this? On top of this, you can also use queries. You can also specify like variables. So, you can also use variables. So you can actually say that this variable, you can define a query and then specify some variable and then send the query text and the variable in a separate, as part of the same HTTP request. This is actually great because you can make sure that you keep the same text and you don't concatenate things and so on and so forth. Normally, this leads to more secure code, so it's a good habit to do that. So don't concatenate your strings, but use variables instead. GraphQL is a fantastic rich ecosystem, and we'll see a little bit later a demo. One of the greatest things is that it has this web IDE that you can use, such as GraphQL Playground or Graphical, that has autocomplete. So you don't the amount of time it takes to learn to use a GraphQL API, it's very low. So it's very quick to onboard new developers to the API, and it's really, 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 it's a really, really nice developer experience. So on the consumer side, this is pretty great. And it makes prototyping really easy because then I don't need to worry, I need a new backend endpoint for this specific app. I can just reuse what is there. I create new things, and it liberates the teams. But there is a couple of things to be said here. I was once upon a time I was working on I was part of a team developing a mobile app, and we were called in to develop a specific backend for that mobile app, because the internal API was so complex and it required so many API calls to do what the mobile app needed to do, needed the data, that it will result in a so bad experience for the mobile app itself. So what we've done, it's we have built this backend for frontend, but for the mobile app, that actually called the internal API, did some data manipulation, data transformation, and then send the data back to the mobile app. All of these with GraphQL would not have been needed. So GraphQL can really reduce your time to market, essentially, which is great. However, sorry, we did a mistake. Hey, jumped ahead. Okay, so GraphQL comes at a cost. So it's an abstraction layer. Okay, so whenever you add an abstraction layer to your application, either it's a web framework or an ORM or another library that you use to build things, it creates comes at a cost, adds some overhead. So it's pretty normal. Unfortunately, when a few years since 2018, we had a few customers contacting us. Nearform, we are a Node.js, we are a professional services company. So hey, hi, it's here, Nearform, hey. And that they were saying that GraphQL was underperforming compared to REST. And so he said, well, is this Node.js thing? It's just a scam or something. I just say, no, it doesn't sound right. So let's take a look. So we started using our tooling called Node Clinic. You can find it on the internet. And essentially, you can use, for example, Node Clinic Flame to generate a flame graph. And then you can also use AutoCannon, which is a HTTP one-to-one benchmarking tool, to actually create some load. And this is what we got. With a flame graph, so the flame graph show where we are spending most of the time in our application. And this was the place where we were spending the most time, which is enter visitor method. So let's think a little bit about that. I hope most of you know what a visitor pattern is. Visitor, it's a pattern that you can use for it's a pattern to navigate a complex data structure, typically a graph. And it's used in this case to read it's used in this case to process the abstract syntax tree of the GraphQL query. What's an abstract syntax tree? Well, when you receive the query, that needs to be parsed and then executed. Now, it uses the reference GraphQL implementation uses a visitor pattern to actually navigate that tree and do certain things. So for each request that comes through, the server needs to parse the query, produce an abstract syntax tree, and then work that to execute the query. Now, in reality, it works that abstract syntax tree twice. Why twice? First one, it validates it against the current schema. So it says, can I execute this? Yes. Okay, fine. And then it processes it again to actually execute the query. Now, the problem for this is that it's really slow. It takes a lot of time to do that processing. So what we have added is we have added caching. And by the way, this is the dirty secret of all performance engineers in the world. So essentially, if you have a very expensive operation, that you can actually cache it. Hey, so if you send the same query multiple times, you don't have to do the same work multiple times. And we have implemented this on top of Fastify, which is the web framework that Thomas and myself and so many others have maintained have built over the last 4 years. So there is a few libraries that we're going to use. We're going to use Mercurios, which is the Fastify GraphQL library. It was called Fastify-GQL, but it was not really recognizable, and it became a little bit opinionated, so it got its own name. It's also the messenger of the god, right? So hey, and it's this is a query endpoint that just does x plus y, and that's it. So you just specify your schema here, your solvers, which it's the code that will underpin those queries. You pass those in, and it will just work. Internally, it uses an LRU cache. And this LRU cache will cache the stable queries. So essentially, when you build an application, a web app or a mobile app, the type of queries that your server is going to be hit with are very similar. So essentially, they are mostly the same. And I recommend to use query variables for this, because if you use the query variables, you can really leverage this pattern, because the query will stay the same. It's just a blob of text. And then you can use just the LRU. Now, there are other techniques like this called persisted queries and so on and so forth that can be easily combined with this approach to get those stable queries for higher performance. Note that this leads to really nice performance. Okay, and I done this benchmark yesterday night. So essentially, you can use this with instead of Apollo or ExpressGraphQL, which is a really popular implementation. You can use those to you can use Mercurios and Fastify to implement a really fast GraphQL server implementation. And it does a very simple hello world, so don't worry. Like those numbers, real number will be probably lower for everybody, but it's really good. The numbers are really, really good on these. In fact, it's very, very low overhead. However, we are performance engineers, so we did not stop. We kept eating this. And in reality, what we found out was we were still spending some time in processing those responses. So we started thinking, well, how can we optimize this even further? Well, what we can do is on-the-fly code generation. What? Is this safe? Yeah, it's safe. So there is a very nice library built by Zalando called GraphQL JIT. Originally, we built our own, but we have decided, we Nearform built our own, but in the end, when we announced it, those guys announced it after 2 hours. So the reality was that their implementation was better than ours. So we just said, let's just use theirs. We don't need just-in-time compiler for GraphQL. One that works well is perfect. So essentially what it does, it takes your GraphQL query and it compiles down it to JavaScript code that then is executed. Now, because it's the code is actually validated, there is a validation step and a validation phase done by GraphQL. This is safe to do. So it's it's totally fine. Note that the advantage of this grows as many resolvers you add. So the more resolvers you have, the better performance you get, which is pretty fantastic. How does this work? Well, you receive an incoming GraphQL query, and if the query is called, you've never seen it, you just cache it and then interpret it, right? However, if the query is hot, and you can configure this in Mercurios, you can compile it down to JavaScript. And then once it's JavaScript, actually V8 can do its magic and just in time compile that JavaScript to actually machine code. This is fantastic. Let's see how that works. So the V8 optimization program starts with loading some JavaScript code, and it compiles it to some slow but generic binary code. However, when then Node runs this a lot of time, it gets run, it can actually optimize this further. It takes the slow but generic code and add some execution metadata that it has collected. For example, which objects are passed in, which types, which prototypes, all those infos. All of that is called shapes. Now, we know it knows way more on that function that it needed before, so it can take that function and optimize it on some fast but specific binary code. There is also an inverse process called de-optimization when it did this the wrong way, but don't worry about it for now. So what does this give us? Well, great results, because we can actually, on the exact same query, we could lift this even further and putting it almost on par with a REST approach. So it's pretty great. So let's move to the next topic, because this is the question that it comes up all the time, and a lot of people don't really understand this. And this helps. So the GraphQL has a problem with the concept of nested queries. And because most people don't really evangelize this too much, because it shows that there is some complexity behind a GraphQL server implementation that you need to be aware of. So optimizing this bit is actually critical, because otherwise, if you don't do this, essentially all of what we've talked about make no sense. You will see that in a moment. So this is graphical, by the way. So you will see that if you execute the query on the left, we have dogs, name over the name. We are actually calling dogs, and from every dogs, we want all their owners and all their names. Let's imagine that we have a table called dogs and a table called owner. it can also be a collection called docs and a collection called owner if you prefer Mongo or Elastic. If it's Elastic, it's an index. Okay, fine. You can get your name for it. So what it happens, the problem, what happens here is that when we start running this query and we implement this in the most traditional way, you will see that we do one query to get all the docs. But then you'll see that there is this concept of the resolver. So you implement a resolver for the owner property on the doc. What happened then? Well, it does n queries. This is the typical problem of most GraphQL implementation. So what happens here is that you go one query for docs and then n queries for the owners. This is kind of a big problem because it's a 1 plus n queries. Not this 1 plus n database accesses, which is probably going to, or microservices call. This is not going to go well and work well for most applications. So, and in fact, it can even get worse because, you have one query and then you have n queries for the owners and then m query because these can be arbitrarily nested. So a key property of a GraphQL query is that it can be nested and it has a depth. And this depth is actually problematic because, in reality, we are 1 plus m, which, you can be, it can be generalized to in 1 plus n elevated at d minus 1, which is really bad. And it's a lot of queries that can happen. So a solution that comes from Facebook, and Facebook has always said, well, if you use GraphQL, you need to also use data loader, otherwise you're screwed. But this message got lost along the way. I don't really know why, but it got lost. So a lot of people don't know about this. So it's really important when you talk about GraphQL to mention the data loader pattern. What is data loader? Well, data loader is a batching pattern. So essentially, coalesce every same-tick query into a bool query. So what it does is essentially takes, when you are doing the plus n, so in your in the query, what it does, it gets all the queries, it gets all those things, it gets all those requests for owners, essentially database call for owners, and coalesce it in a single batch query for getting all of them in one single go to the database. This actually removes so many problems in GraphQL. So you need to use data loader independently of your GraphQL implementation, of the GraphQL implementation that you're using. You should use the data loader pattern, which moves you to D queries. So essentially, this is the amount of depth, and this is actually good because you have, 3, 4, 5 levels, whatever, and this is the amount of depth that can be done. But then there is a problem because if there's, you can create a query which is as complex as possible in GraphQL. Well, in Mercurios, what you can do is that you can actually limit the max depth. So what is the maximum depth of a query? Essentially blocking the maximum amount of queries that you can do on a system. Oh, I didn't update this. This is still the new name. Haha. So you see live slide editing. Hey, come on. Here we go. So what it happens is that you have what you specify, instead of specifying the resolvers, you just specify the loader. You can pass in a loaders property like this, as you can see here. This loaders property, it's essentially returns a queries object, and this query an object property that you can actually go and use to query your DBs, with. So essentially, pretty great, works super well, and it resolved the problem perfectly. Now we're talking on probably the last topic. I am probably a little bit low on time, so I might just skip the demo. We'll see. So one of the key things about GraphQL is that you can create you can actually use it to structure a microservices network. So you have your GraphQL server, but that server does not need to be a full monolith with everything. You can actually divide the functionality of that server into multiple small servers. And federation, which was invented by Apollo, is a technique to split a GraphQL endpoint into multiple microservices, or expose a single GraphQL endpoint from, multiple services, which is pretty great. So how does it work with Mercurios? Well, we implemented this from scratch, and you can specify, you can enable, please enable the JIT. And then you can, as you can see, there is these services, and you can specify the services that you want, which is nice, and essentially point it to a location. And then you can actually also implement them. And in order to implement them, for example, you need to use some keys, use some directives, and so on and so forth. Please check the docs. The most important part is that you use these loaders to implement the resolve reference. So essentially, when you just join two services, it uses the data loader pattern and these loaders concept to query the database. Otherwise, it will actually kill the performance of your microservices network, which will be very hard to track down. So yeah, remember to implement the data loader pattern. So how does this perform? We measure this, and yeah, it performs way well. It's than the original implementation, with better latency, better throughput, and more requests per second. So hey, pretty great. So Mercurios still doesn't have its logo, but this is the Fastify one, which is pretty great. And it's I might just say thank you, but I might have some time for a demo if you pass me the demo thingy. And so run dev. Here we go. Sorry, folks. I have this running over here. Wait. Let's do this. Kill all node. Here we go. Okay. Fine. It started on localhost 3000. So we have a few endpoints. One is basic, and this is let me zoom in. Okay, hopefully you can see this well. Yeah, I know, Thomas. You need to increment the font size. So hey, so as you can see here, you can. This is graphical. So in graphical, the nice thing about GraphQL is that you have autocompletion. Why? It's the actual GraphQL endpoint is self-descripting. So you can actually ask the dogs for all the names of the dogs. Then you can ask for the owner, and you want the name of the owner, right? And then there's not other properties. Note that you can also explore this in the docs here, and you can see that there is things. Now, if we move to the nested case that we were talking about before, this is the same thing, okay, as we can see, but I changed the URL, and I can add here the address and get city. Here we go. Now you see all of this. Now let's see how this is implemented, okay? So I can open this up and note that Vim is best, okay, by the way. And so we can open the nested, edit anyway. We can open the nested loaders, and you can see that we implement this with using some resolvers. So there is the owner resolver and the address resolvers that get this from a database. So what does this do in reality? As you can see, it does getting all dogs, getting owner, then getting address, and getting address. Because essentially, these functions are getting called once for every human and once for every owner. So we are going for 7 query on the database for one simple query on GraphQL query, which is not great. With the data loader pattern, I need to type this better. With the data loader pattern, instead, what happens is that it performs 3 queries. So you see getting all dogs, we do a bool query, owner, and then another bool query. How is this implemented? So we'll here and edit anyway, because it's open somewhere else. And we have it in here. You see that we use loaders, we got those queries, and it's we do the same for the addresses as well. And with this, it actually performed only 3 queries, not 7. So we have actually limited the amount of queries. More importantly, is not dependent on the amount of queries, on the amount of data that you are transferring, but is only dependent on the amount of on the depth of the query, which is something that we can limit with an option, which is really important. So having said this, I just wanted to thank you for listening to my ramblings. I hope I am on time, or not late, or not too much early. Please follow me on Twitter at Matteo Collina. If you have any questions, you can reach me out at matteo.collina@nearform.com. I'm active on both, but I prefer Twitter if you want to ask me some questions. Note that Nearform is a professional services company. So if you need any help with JavaScript or Node.js or React or React Native or a lot of other things, please reach out. We can definitely help. We are not hiring at the minute, but we will do a big hiring push on next year, on 2021. So if you are interested in joining, we are based on 20-something different countries, so maybe 24, 23, I don't remember, all over the globe. So we are remote for, well, everybody's remote with COVID, right? But anyway, we are really distributed all around the globe. So if you want to join, if you're watching this and you want to join us, please reach out. Having said this, I see Thomas is back, so maybe I can stop.
Yes, I'm back.
I can stop sharing my screen, but and then I can move you here so I can actually see your face while talking. So hey.
Hey. So well, thank you for the talk, Matteo. That was really impressive. I mean, the numbers are insane. So great work, and also great job to the organizers, because we saw before with the other Thomas what prototypes are, how they work. Now we saw how V8 is optimizing prototypes. So perfect timing. And I'm this close asking you about ORMs, and go to Twitter for going by. But I'll stay on topic. I'll stay on topic and ask you GraphQL related questions.
Well, so, you know, there are ORM related to GraphQL related questions. If you want to, if you want to ask, I can delve into.
That's true, but we'll have a talk later about this. So let's wait later. You can ask if you want question later to the next speaker. So
and do a panel maybe.
If you like. So when do you think someone should use GraphQL over REST, or if we should just drop REST completely?
So,
what's your opinion on this?
The best spot into which we can use REST instead of GraphQL is when you have separate teams. So if you have a small team that can do the front end and the back end of a system, and I'm talking a small 4, 5, 6 people, normally it's really, from my point of view, it's okay to use REST. And the reason for that is because the skills on updating the backend are within the same team. So essentially, the delivery of new features can actually move really fast. However, if instead there is a front-end or mobile team and then there is a backend team, let's imagine a typical 2-week sprint scenario. If the mobile team needs a new endpoint or some changes or a new REST API, you need to wait at least 2 weeks to get that done. So essentially creating different incentives and creating problems of communications and so on and so forth. So the reality is that GraphQL is great in solving those situations because it removes, it greatly simplifies, greatly reduces the communication needed between different teams. So which the result makes is like saves a lot of development time to companies, which is probably the thing that costs the most these days.
So we can also say GraphQL is a tool for solving organizational problems,
as microservices are. So it's essentially it's a tool to it's a technical technical solution to organizational problem. Yes, which works great and beautifully because of that. So it's just like brilliant, by the way. A lot of people will say that this is not needed, and I'm telling this is not needed if your goal is to keep it as a small team. There is this fits into the big discussion of the majestic monolith of David Heimer Hansen and so on and so forth. So if your goal is to keep a small team forever, then of course, don't even think going GraphQL. If you're a solo dev, you want to try it to learn it, but if you're just developing your own things, probably not worth the while. If somebody else do the backend for you, for example, using Azure or Prisma or one of those PostGraphQL, then you can actually use those tools, but don't go and implement it yourself because you will be burned quite badly because it's another level of complexity, right?
Mm-hmm. Yeah, that's true. So you saw us, we're talking about optimization Clinic and Clinic Flame. So a question I want to ask you is, how can you identify bottlenecks and performance issues in your code? Since you talk about that, and you saw also, you've shown how much you can improve your code, but starting and looking at these graphs.
This is a question. So this is a nice question. Unfortunately, it takes probably a few hours to answer this. So I'll try to condense.
You have 5 minutes.
5 minutes, okay. I can do it.
Let's see how performant you are.
Okay, so there is one of the key things of an application is if let's say you need to think about data as it's a flow of water in pipes. So you have data that is flowing. Okay, it comes from your database, which is your source, and then you have a river of data, and then it goes down. Blah, blah. Now the problem with this is that it's if there is a bottleneck, if you squeeze the tube in a single spot, then the data will start coming slowly, way more slowly. After that, solving performance problems is exactly like finding the exact point in your long pipe where there is a bottleneck, when the tube gets compressed. And once you find that, you can just need to widen that up. Okay, and you open it up, and after you do that, then the data can flow faster. They can flow more data. But there will be another one. So apparently, if the problem is that if there is a bottleneck that can limit your throughput to, I don't know, 500 requests per second or 1 megabyte per second, and there is another one that limits it to 1 megabyte and 100 per second, removing one will just move you to the next one. So essentially, what those tools do is help you find the next bottlenecks. Okay, the next bottleneck. When do you stop? When the performance is acceptable. There is always one. Okay, so in some cases it might be the database the connection to the database or the database itself. In other cases, can be the query that you run with the database. In other cases, can be the operating system and the configuration of the network stack. It can also be the type of instance that you're running with on your cloud provider. So you see that there is network performance, and they normally tell you about the bandwidth of those, and that's also a number that you need to be careful and know about. It took me, I was beaten badly by that, so I remember it, and that's it. So that's essentially the rule. You identify the bottleneck, you solve it, you find the next one. you finish when either you burn all the money you have, or you say, or
it's good enough.
You are happy with the result. So
okay, so basically your job is to be a plumber. That's
what my high school teacher was telling me all the time. So they should just stop studying and go be a plumber. So that is a nice story there.
Okay. But I do remember actually in the very first early days of Fastify, this is a shameless plug. So it was 4 years ago. This week is the birthday of Fastify, 4 years ago. And I remember in the first days when we were trying to optimize way too much, probably, that you wrote me a message. Hey, I think I've reached the maximum amount of requests you can send to AWS because I'm getting back very, very weird errors. But something like that. I don't know if you recall this. I remember the message. I should search it and I don't know.
Yeah, totally. It happens. It happens me all the time, to be honest. So it's actually, especially if you do load testing, you can actually peg the CPU, the instances very quickly. They don't. It's they don't have, only the higher tiers one have really big bandwidth, but this is not really super advertised. They always tell you, well, you have this amount of CPU, this amount of network, but they don't really say how much bandwidth you have. And this is actually kind of instead the biggest problem whatsoever, because if you can have the fastest CPU possible, the amount of memory you want, but if you can get the data out, there's no use for that.
Yeah, so we can say that a take-home message from this is performance problems are not always in your code, so take care about this.
Yeah, but most of the time they are. So you can do something about them in your code. So you can.
That's also true, yeah.
So essentially, that TCP has head-of-line blocking, for example, but then you can use certain techniques to actually avoid head-of-line blocking on TCP connections.
Yeah, that's true. So, we are almost
I wanted to keep this going. This was so fun.
Yeah, well, there is a chat in the event if you like to talk. And so thank you a lot for your talk, Matteo. It was, again, super interesting.
Bye-bye.
And see you next time, again, hopefully in person.
Hopefully soon. Bye-bye.
Bye.
Bye-bye.